In this video, we want to repeat the example for the reading rates of 6th grade students. We've done this by hand in the previous video, and now we're going to use the TI graphing calculator to repeat the problem. So we know that the reading speeds of 6th grade students are approximately normal, and that they have a mean reading speed of 125 words per minute with a standard deviation of 24 words per minute, and we have 5 parts to this problem. So the first problem was to draw the normal model. Then we wanted to find the probability that a randomly selected student reads less than 100 words per minute, that a randomly selected student reads more than 140 words per minute, that a randomly selected 6th grade student reads between 110 and 130 words per minute, and then would it be unusual for a 6th grader to read 200 words per minute or more than 200 words per minute, I should say. Okay? So previously, we had created our normal model here. So we have our normal model. This was when we did this by hand. Okay, and in part B, we wanted to find the probability of X being less than 100 words per minute. And so we converted the 100 to a z-score, which was negative 1.04. Okay, so if we find the area to the left of negative 1.04 under the standard normal, that will be the same as the area to the left of 100 approximately on this normal distribution. So the only difference is that we could use our normal distribution on the calculator. So I can go to second and distribution on the calculator and use the normal CDF command to find the area to the left of negative 1.04. So we don't have a left bound, so we would use a big negative number, negative 10 to the 99. Our right bound is negative 1.04, and so that gives us normal CDF, negative 10 to the 99th to negative 1.04 with a mean of 0 and standard deviation of 1, and so that would be about 0.1492, which is the answer we got when we did this by hand. Now, the only difference that I want to show you here is the truth is with the calculator, we don't even really have to find the z-score. So when I use the normal CDF command, I can do it directly from this problem. Okay, so I don't have to find the standard normal equivalent. I can go directly from my original model. So in my original model, I need to find the area to the left of 100. So my lower bound is a big negative number, negative 10 to the 99th. My upper bound would be 100. But to use this model, I just fill in the mean of 125 and the standard deviation of 24. So if I do that, I get normal CDF, big negative number, to 100 with a mean of 125 and a standard deviation of 124. And that gives me 0.1488 if I round to 4 places. So if I use the normal CDF command, again, it's normal CDF. I don't have a left bound, so I use a big negative number, negative 10 to the 99th, to 100. That's my right bound. The mean is 125, and the standard deviation is 24. And when I did that and round to 4 places, I get 0.1488. Now notice there is a slight discrepancy between my answer here and my answer here. And that is because I had to round my z-score. So the fact that I rounded my z-score actually made my probability off by a few 10,000ths. So this is actually a more accurate probability based on my model. In the same way, I could do this problem. In part C, we wanted to find the probability of selecting a 6th grade student that reads more than 140 words per minute. So again, with my calculator, I could do normal CDF. This time we have a left bound of 140. Right bound, we don't really have one, so we use a big positive number, 10 to the 99th. The mean is 125, and the standard deviation is 24. So again, if I bring in my calculator, I can go to normal CDF. This time I have a left bound of 140. The right bound is my big positive number. My mean's 125. My standard deviation is 24. And so I get .2660 if we round to 4 places. So this gives me a result of .2660. Now again, notice there's a little bit of discrepancy between this answer and the answer that we got previously. The answer we got previously is off a little bit because we had to round our z-score, and that gave us error. Had we not rounded that z-score, then we would have gotten the exact same answer. Continuing. So in part D, we wanted to find the probability of selecting a 6th grader who reads between 110 and 130 words per minute. So again, I can use my calculator for that. So my command will be normal CDF. We're going to go from 110 to 130 with a mean of 125 and a standard deviation of 24. So typing that in my calculator, so normal CDF, we have a left bound of 110, a right bound of 130, a mean of 125, a standard deviation of 24, and so that gives us the result of .3165. So this is .3165. Again, previously we got 3189, which is off a little bit because we had to round our z-scores. This is actually a more accurate answer. Okay? Last but not least, for part E, we wanted to find the area to the right of 200. So we can do that with normal CDF. We have a left bound of 200. We don't have a right bound, so we use a big positive number, a mean of 125 and a standard deviation of 24. So again, going to normal CDF, we have a left bound of 200, a right bound of a big positive number, mean of 125, standard deviation of 24, and so that gives us, now notice this is scientific notation. So this answer is 8.89 E negative 4. That E is scientific notation, so that's times 10 to the negative 4, which means the decimal point really moves 4 places to the left, so 0.00889, and so if we round that to 4 places, that would be .0009. So we get the result of .0009, which is the same result we obtained previously. So even though we rounded our z-score here, it didn't result in significant error in that particular case. So we have solved our reading rates problem using the TI calculator. So our next video is going to be doing the same problem a third time, showing you how to use StatCrunch.